Okay, ladies and gentlemen, so let's get started with today's video lesson. And today we're going to talk about reciprocal identities. Now, in class, we discussed some of the reciprocal identities that we've already worked with, such as, for example, the sine or the cosecant, is the opposite of the sine. And for example, we know that the cosecant is the opposite of the sine, right? And it equals 1 over the sine. And we know that the secant, for example, is 1 over the cosine. Trying to write this almost as fast as I talk. I'm sorry. So the secant is the opposite of the cosine, which is 1 over the cosine of c. So in this section, we're actually going to begin to talk about the reciprocal identities. Now we've seen these and these examples, which are examples 1 and 2 of this section. We're not only going to review the trigonometric or reciprocal identities that we've already studied, such as the cosecant and the secant, and then, of course, the cotangent, which is the opposite of the tangent, but we're also going to see other reciprocal identities, like, for example, like the ones in example number 2. So that being said, let's go ahead and review some of the reciprocal functions that we've already used so far in the course. Okay, now I'm leaving these here because we might need them a little bit later on, maybe not. And if we don't need them, at least they're there for reference or for decoration purposes. Now let's look at the first example. It says, if the cosine of z, or theta, if the cosine of theta equals negative 1/2, find the secant of theta. So we know that we have to use a reciprocal identity, which is pretty much taking one of the trigonometric identities and flipping them over, right? And we discussed that in class and we went over various of them. Now we know that the cosine of theta is negative 1/2 when we're being asked to find the secant. So the trigonometric identity, or the reciprocal identity that we would use in this case, is the secant of theta, which is 1 over the cosine. So what that means is now this is going to equal to, or the secant of theta is going to equal to 1 over, right? That, remember, the reciprocal identity says that the secant of theta is 1 over the cosine. So we're going to apply it here. And the secant of theta is going to equal 1 over the cosine of theta, which is negative 1/2. So we're going to write that as a complex fraction. And we're going to say over negative 1/2. And what we're going to do then is simply just invert the fraction. Okay, so whenever we're dividing a fraction, we're going to invert the fraction. So we're going to flip this upside down, and I'm actually going to use a different color to illustrate it. And this is going to be the same as 1, which is right here. So I'm actually going to draw like a little arrow to indicate the steps. You're going to say 1 over, or multiplied, by the reciprocal negative 1/2, which is negative 2 over 1, which is obviously negative 2. So 1 times negative 2 over 1 equals negative 2, which means then that the secant of theta, equals negative 2. Okay, equals negative 2. Now let's go ahead and do the example 1b. Example 1b says, if the sine of theta is the square root of 3 over 2, find the cosecant of theta. So we already used the secant formula. So let's go ahead and eliminate this formula, right? And we're not going to use the cotangent. So let's go ahead and eliminate it right now. So according to this exercise, we're being asked to find, if we have the sine of theta, which is the square root of 3 over 2, find the cosecant of theta, and the cosecant of theta will be found using this reciprocal identity, which is the cosecant equals 1 over the sine. So what we're going to do is we're simply going to say, well, the cosecant equals 1 over the sine. So we're going to say the cosecant equals 1 over the square root of 3 over 2. Now, remember that when we're dividing a complex fraction, we have to then reciprocate that. So this is going to be 1 times 2 over the square root of 3. So now I have the reciprocal of the square root of 3 over 2, which is 2 over the square root of 3. There we go. Let me see. 1 times 2 over the square root of 3. Now, 1 times 2 over the square root of 3, or any number multiplied by 1 is itself. So we say this is going to equal 2 over the square root of 3, but I need to rationalize my denominator. And rationalizing my denominator means that I cannot have the square root of 3 as my denominator. So I simply say the square root of 3 over the square root of 3, right? I'm going to multiply 2 times the square root of 3 by the square root of 3 over 3. And this is going to actually equal 2 times the square root of 3. Well, it's obviously going to be 2 times the square root of 3, and that's pretty much not going to change. And then the square root of 3 times the square root of 3 is the square root of 9, which is actually basically just 3. So your answer should be 2 times the square root of 3 over 3, and that is, in that case, how you would find the negative reciprocal of the function. So that being said, let's move on real quick. Having some technical issues here, guys. Hopefully I can solve that as soon as I can, and we can get back online real quick. So again, what we're seeing is just basically the reciprocal functions that we already studied, such as that the cosecant is the opposite of the sine and the secant is the opposite of the cosine. But those are not the only ones that we're going to see, right? Which is going to bring us to our next example real quick. And okay, so the last example, or not the last example, let me go ahead and erase this so I have some space. So again, just to kind of recap where we left off, well, we know that the cosecant is the opposite of the sine, so that'll be 1 over the square root of 3 over 2. And that would lead me to flipping this denominator upside down, or flipping it over, and turning it into 2 times the square root of 3. 1 times 2 times the square root of 3 is 2 times the square root of 3. Then I rationalize the denominator by multiplying by the square root of 3 on both sides. And my final answer is 2 times the square root of 3 over 3. Now, that being said, guys, let's actually go ahead and find the last, or do the last example of this part so we can move on to the second example. So I'm going to go ahead and erase this so that way everything doesn't look like it's scrunched on top of the other. If you guys have any questions, you can always pause and rewind the video and hear me as many times as you need in order for you to understand the exercise. So let me go ahead and continue to erase all this, and that way we can have the space so that we can go over the last example, or example 1C. So it's basically the first example, but just C, or the third, I guess, subtopic of that example. So give me 1 second. Give me one second. This is kind of funny. Okay. All right, doesn't matter. So it says if the tangent of theta equals c, find the cotangent. So we know that in order to find the cotangent, the reciprocal identity of the cotangent, or one of the reciprocal identities of the cotangent is 1 over the tangent of z. 1 over the tangent of theta. So what we're going to do is basically just say, well, cotangent of theta equals 1 over the tangent of theta, which is what we have. And what the problem is basically telling us is that the tangent of theta equals c. So we would just simply say, or change the value of the tangent of theta to c, and that would mean that the cotangent of theta in this case equals 1 over c, and it's a variable, and basically it'll be 1 over c as long as c, let me write a comma here, as long as c, well, that's not a pretty comma, as long as c is not equal to 0, because remember that in a denominator, c cannot be, or the denominator cannot have a 0. So now we're going to talk about other types of reciprocal identities, and more specifically, we're going to talk a little bit about the what are known as the quotient identities. Now, we've seen the quotient identities, and we've seen them mainly in the in coordinate planes is what I'm trying to get at. But two very, very common quotient identities are, and I'm going to write them here, are actually the tangent and the cotangent. So I'm not going to erase this completely, and I am going to erase this though. So we know the reciprocal identities, like the ones that we just saw, where the secant is 1 over the cosine, and the cosecant is 1 over the sine, and the tangent is 1 over the cotangent, and so on and so forth. But we're going to see quantity reciprocal, or quotient reciprocal identities. And the two and the two that we're going to see are the tangent and the cotangent. So we know that the tangent of theta, if we have coordinate plane, is y over x, and the cotangent of theta on a coordinate plane would be x over y. But another way of expressing these quotient identities is by saying that the tangent of theta is the same as saying sine over cosine. Now, this is really used a lot in physics as well, when we're studying vectorial motion. So if you are to see this in physics again, or are taking physics now, this can be, remembering this can be of help. And so the tangent of theta equals the sine of theta over the cosine of theta, and of course the cotangent of theta would be the reciprocal, and this would actually equal the cosine of theta over the sine of theta. So the cosine of theta over the sine of theta. over the sine of theta over the sine of theta. So the cotangent of theta over the sine of theta. And that is going to help us to work with the following exercise, which is example number 2. Now let me change that to black again. And the problem says, and let me get my spotlight so I can read it to you guys. And it says, if the sine of theta is 3/5 and the cosine of theta is negative 4/5, find the tangent and the cotangent. So what we're going to do is we're going to plug these in to the formulas that I just wrote here in red. So they want us to find the tangent and the cotangent. Well, to find the tangent, we know that is the same thing as saying if we have quotient identities, which are being used in this case because 3/5 and 4/5, or negative 4/5, excuse me, are fractions. So we have the tangent of theta, and the tangent of theta is going to be the same thing as saying sine over the cosine. So that would be the same thing as saying 3/5, which is the sine of theta, 3/5 over the cosine of theta, which is negative 4/5. And this, of course, is going to bring us to having us divide the fractions. Now, remember that whenever you guys divide fractions, you're multiplying by the reciprocal. So this is actually going to turn into 3/5, which is the first fraction, multiplied by the reciprocal, which is negative 5/4. Negative 5/4. So what you're excuse me, what you're going to do in this case is you're going to multiply, pardon me, this. Now, when you again, I'm sorry about that. When you are multiplying them, we can use cross cancellation. And in this case, we can cross cancel 5 and 5. And this would be 1, as would this one be. So that means that our answer would be that theta equals negative, the tangent of theta equals negative 3/4. Okay, so the tangent of theta equals negative 3/4. So we know that the tangent of theta, let me write it in a different color. Yeah, I like using the blue. So the tangent of theta, equals negative 3/4. Now, you are probably saying, well, I have to do the same process to get the cotangent of theta. And actually, no, you don't. Because remember that the formula says that the cotangent of theta is the same thing as saying the cosine of c over the sine of z. And all you really need, or even another way of saying it. So let me get my spotlight. So basically we have the tangent of theta, and you would probably say, well, then that means that I have to do the same process to find the cotangent of theta, because the formula says that the cotangent of theta is the cosine of z over the sine of z. And that's not necessarily the case, because remember that the cotangent is the reciprocal of the tangent. So that means that if my tangent is negative 3/4, then the cotangent of theta is actually the opposite, which would be negative 4/3. So we simply take our answer that we got for the tangent of theta and just invert it into negative 4/3. So I actually went ahead and worked with the tangent of theta, and then from the tangent of theta, I from the tangent of theta, I actually went ahead and got the cotangent. I could have easily have used my cotangent function because I have the sine and the cosine, and then basically flip that upside down and got my tangent function. So guys, this video lesson has been a very brief introduction to identity or reciprocal identities, excuse me. Hopefully this video is helpful, and we'll see each other in our next class. So bye-bye.